we talk about major structural damage 27 February. General aspect of earthquake. The February 27, 2010 at 3:54 a.m. local time, an earthquake of magnitude 8.8 on the Mercalli scale struck central Chile. The 27 February earthquake in Chile is one of the highest magnitude earthquake recorded in world history. Scientists have records. The earthquake on February 27, 2010 of moment magnitude 8.8 was centered off the coast of Copquecura, Biobío region. The intensity of an earthquake is measured with the Mercalli scale. This scale has 12 degrees and measures the intensity at a specific location. Table 1 shows the intensities recorded in different cities for the event on 27 February 2010. It can be seen that the big valley was recorded in Conception, reaching valley of 9. The extent of the rupture zone and the affected area, as well as the number of structures that were subject to earthquake, the same according to modern cost of earthquake resistance. But the information of what worked and what didn't, it is essential to assess the state of the art seismic resistance design. And the earthquake resistance design of a structure in Chile is governed with 3 official rules. NSH 453 of 1996, NSH 2369, and NSH 2745. In terms of structural design, the date of the earthquake, the design of reinforced concrete building, it was governed by AC 318 of 95. 95. Sorry. Given the implementation of this chapter 21, the 3 seismic zones as areas of high seismic risk. In the case of steel, given the lack of an official Chilean standard design, the practice was to use the provisions of the AC, taking some of the recommendation of the seismic provisions, or the provision of the NCH 2369 for the steel structures.
Effect on reinforced concrete structure. Reinforced concrete structure were observed damage in several cities of the territory concerned, among which may be mentioned Concepción, Santiago, and Viña del Mar, the latter in the Pacific Ocean. The failures were problems that might be associated with construction defects such as structural or detailing. Several buildings have damage to reinforced concrete walls at the level of the first floor or the first basement, where parking for vehicles usually are located. At this level, the structural configuration in many cases has a central longitudinal corridor walls and the sides connected to the transverse wall, forming a wall in T. In other case, this transverse wall is not directly connected to the longitudinal wall, forming a rectangular walls. The failure observed in this structuring consists of a horizontal crack propagate along the core wall, covering a range of about 40 centimeters high. Another type of failure observed in reinforced concrete building was generated by coating. It presents both from product drilling and coupling element in walls. Modification to standard reinforced concrete design. Based on the observed damage and emergency put for the design of reinforced concrete, it was enacted. Overall, the changes are focused on problems observed in walls. The main changes are summarized below. Limiting axial lag on walls to reduce the probability of observing and compressive failure. Prevention of buckling and fracture of strengthening small and well-anchored transverse reinforcement. Prevention of shear failure, 1.4, amplifying solicitation considered for design. Use of transverse reinforcement in longitudinal reinforcing joints present significant amount of armor or concrete cover on these inadequate bars for proper straight transfer. Limitation of the diameter of longitudinal and transverse reinforcement to promote good concreting and confinement on the edge of wall. It also specified a minimum wall thickness as LU divided 16, where LU is not supported over walls to prevent or minimize the overall buckling of this element.